Hello. This video, I'm going to introduce a research study, a pilot study we have just recently done that uses the high-frequency vibrometer vibration sensors to track what a construction worker is doing or what tools that he or she is using. This is the hardware we developed. We used a Raspberry single-board computer, the vibrometer. This is a closer look of the single-board computer. And this is the vibration sensor we are using. We are using one manufactured in China, and it's called the CJMCU, and the model number is LIS2DH12. So this one is able to track 5K hertz and 3 axes, X, Y, and Z. Then we performed the preliminary study. We basically attach this high frequency vibration sensor to the wrist of your hand, and then we hold different tools or do different things, and we track the vibration data. For example, in this experiment, we hold the drill, and this one, this is the impact drill mode. So we are punching a hole on this wood plank, and this one, we're drilling a hole. And we also use this chainsaw. So we just performed the full test. And here's the result. So this is the first one holding a walking drill. As you can see, we performed the FFT analysis, the spectral analysis, and this figure shows the spectral density graphs for the 3 axes, X, Y, and Z. And we can learn two things from here. So first, a lot of useful information actually comes after 500 hertz. It's kind of like, for example, in this one, a lot of signature information actually comes between 500 hertz to maybe like 2.5 K hertz. But most of the variables, like a smartphone or smartwatch, they are only able to track up to 100 hertz, which is pretty much here. So it can be very difficult for you to classify the activity based on this one. And this is test 2. The impact drilling a wood plank. And as you can tell, the XYZ pattern look very different from the first test. But again, if you only compare the first 100 hertz, it can be difficult for you to classify the two activity, because most of the information comes, especially here, like about 1K hertz after 500 hertz, and like here, 500 hertz to maybe 3K hertz. This is the test 3. Drill a wood plank. Again, most of them comes after 500 hertz. I have to say probably to 1.6K hertz. And this one is the test 4 chainsaw. And again, the Z one, the Z axis, you can see it comes after 1.2 or 1.3K hertz. So the two things we learned here is, first, high frequency vibration data should be able to better classify the construction activities, because more information are hidden here, the higher frequency. Oh, by the way, please ignore the unit here. It's supposed to be 1K, 2K, 3K, 4K, 5K. And the second thing is, looks like different construction activity will generate different spectral density patterns, and we should be able to use them as a predictor to classify your current activity. All right, thank you.